Thank you so much, everybody, for joining us today for the Type 5 reasons to start using Zirlux Transition. It's my honor and my pleasure to be here with you and share a little bit about what we've gone through because I was a part of the launching process and validating process. So I'm happy to share a lot with you as far as transitions, which I think is head and shoulders above any other zirconia that is currently out there. And I'll share with you why. So what is the transitions, the Zirlux transition? It's really a different, as I said, it's a 4Y zirconia. So that allows us the ability of having an incredible anterior translucency while having the multi-layer. Now, when I say multi-layer, this is where, as far as zirconia, it's really head and shoulders above the rest because it falls within the category of multi-layer, but it's really not a multi-layer. It's really more of a transition, and hence the name, because that comes from the way these pucks are manufactured with a hybrid hydrocolloid kind of processing, whereby they create the raw materials in the zirconia that they make them into fine particles so that as they're manufacturing it, and it's a proprietary process, that it becomes almost, it's not liquid, but like liquid, that they can actually layer it in such a way. So there's no multi-layer as far as lines of demarcation. It's a true transition where from the cervical, you get a more increased chroma, and therefore you, as it gravitates more further up to the incisal edge, depending on the structure of the shade, there's more yttria introduced and therefore translucency. And I'll share with you how amazing, because it truly is very akin to ceramics in the way we build up ceramics. So I'm an MDT and a ceramist, CDT ceramics. So like I always build everything from within outwards, right? Because that's exactly how a natural tooth does. And we've struggled for many, many years now with achieving the same results. So for two factions, number one, the way it behaves and how the construct of it, or the geometry, as I shared with you, from within outwards, as well as how light behaves when it hits zirconia. That's been a challenge up to recent with, especially I'm happy with the transitions because it really mimics the way not only does a natural light behaves with the tooth, but also the way it's formulated and the way it's manufactured. So it's manufactured in a transition whereby from the cervical, there's a greater level of chroma, and as it gravitates towards the incisal edge, there's a balance rather than lines of demarcation with multi-layers. There's a balance that your eye cannot decipher, and it transitions through all the way to the incisal edge where you get the most amount of translucency. And it's really an incredible translucency, and again, different than the typical zirconia that we're accustomed to, because it behaves more like ceramic, more like glass, more natural opalescence. But this particular, the transitions it has a posterior strength, and a strength anywhere from 1100 to 1200 megapascals. Now, why the difference? The difference between 1100 and 1200 megapascal is as the further cervical it is, the more zirconia, sintered zirconia particles there are. And then as you gravitate toward the incisal edge, you have more yttria component, and it is a little bit weaker, but still 1100 to 1200 megapascal is significantly higher than some of the other restorative options. Now, this really provides a great benefit because it allows you to do from a single anterior restoration with a highly aesthetic outcome to a 14 unit to an all on X type of restoration. So that's where this is really a very unique and truly head and shoulders above any other zirconia as far as I consider it. It is a 4Y zirconia, and it's ideal for both anterior and posterior. And what I love about this very much also is that it's made right here in the US. It's proudly made here in America, and it's something that has been a lot of R&D and a lot of effort and investment and resources have been put in to bring this to market, which is, I think, is again a phenomenal zirconia. So now, how does that compare? And as we said, where are we looking at? We're looking at the aesthetic end of zirconias, because this is in fact a premium zirconia, the transitions. So looking at kind of like the staple of what aesthetic, the lithium disilicate or the Emax, you're looking at a 420 megapascal in strength. And as you continue on to going towards the right, you see that the highest that it gets to is the cubics or the 3M, which is only at 800. The Zirlux Transitions is head and shoulders above because it's 1100 to 1200 megapascals. But not only do you assure a high level of aesthetics with the transitions, but one thing that I want to note also is all these that are to the left of the transitions are really limited to the how long of a span bridge you can do, right? IPS Emax, certainly you can do up to a 3-unit bridge anterior of the premolars. Katana similarly, and as you keep going, none of these can you do a 14-unit all on X type of restoration that is implant supported. So this is, imagine having the ability of doing a complete full mouth restoration with having the high aesthetics of what we're looking for, which I would even argue that sometimes it's even better because of the way they have what's considered a smart incisal technology. And the smart incisal technology really provides, they looked and mimicked at what would be the light transmission in ceramics, which again correlates to what it would be with natural teeth. So there are components in the manufacturing, and again, it's proprietary manufacture where, as we know from ceramics, as we know from natural teeth, if light hits the material and bounces back, it's opacified. If light hits the material and reflects, it's translucent. And if light hits the material and it goes through and through, it's transparent. There's elements of all three of how light behaves within the transitions. The R&D team that put this together really thought long and hard and made not only the manufacturing allow it to mimic what is like in a natural environment or in ceramics that we're accustomed to, but even the way the light penetrates, it changes the way the material exhibits. So when it blends into the mouth, it blends really well when it blends into the mouth. So it's something that, again, zirconia traditionally hasn't been the case, right? In zirconia traditionally, there was always a challenge with the value. It was always too bright. And when you put it into the mouth, sometimes it even showed even brighter because the natural teeth just absorbed light in a different way than that zirconia did. Well, I'm happy to say that from all the cases that I've done with the transitions, that's been quite the opposite experience. In fact, when you put transitions similar to natural teeth and you blend it really well, not only do you get a consistent and repeatable shade result, because that's just from the manufacturing of it or fabrication, the proprietary manufacturing of the pucks, but also the way the light behaves is similar to natural teeth. And even if you're doing next to a Emax crown or something like that, you can match it better than what our predecessor zirconias have done. So I'm really optimistic that, and that's why in the beginning I said it's truly head and shoulders above other zirconias because of the results. As a ceramist, I'm very happy and to see the results that we're attaining with the transitions. Again, not only the proper shade, but it's also allows the incisal and the light translucency, the light penetration to really come out. So it provides us for, either a single restoration, a 3-unit bridge, a 14-unit case, a 28-unit full mouth rehabilitation, or even all on X type of thing, restoration or solution that you can provide the patient with a really lifelike and aesthetic restoration in a big way. So it provides also the opportunity in your laboratory to mainstream the inventory, right? So now most laboratories have perhaps 3 or 4 different zirconia lines to accommodate different indications. So if you're doing single restorations, you probably have a go-to zirconia. If you're doing 3-unit bridges, if you're doing a long span, now with this transition, and what I'm also very excited about, in a laboratory, you can reduce your inventory whereby you can utilize one line for, like I said, everything from a single central to a 14-unit complete mouth rehabilitation or complete arch rehabilitation, I should say. So there's tremendous benefits with employing or deploying the Zirlux transitions within your repertoire in your laboratory. Now, another benefit, and the title of this is the top 5 reasons, is also the sintering parameters. Now, sintering parameters, you have multiple sintering parameters for the transitions. You have a 9-hour, which is probably what most laboratories do, which is an overnight 9-hour sintering cycle. It is suggested for long, long span bridges in particular, but also I want to say when you have a large mass of material, it just zirconia and the nature of zirconia and how material science behaves is that it absorbs heat and maintains heat. The bigger the mass of the material, the more absorption of heat will be. If you're too quick with your sintering temperatures, or especially your decrease numbers, meaning your cooling, it may create if it's a very large mass, so certainly a large bridge, it may create a heat shock and create dire consequences, which is not something that we want. So there is the 9-hour cycle, but you can do a tremendous amount of restorations or solutions within that. And it doesn't matter if it's a long span bridge or multiple individual, whatever you can fit in there, it's perfectly fine, the 9-hour sintering cycle. There is also a 7-hour sintering cycle, which again, it's more connected to the mass of it, but as a rule of thumb, it's mainly for single crowns not exceeding 30 units. And up to 3-unit bridges. Again, depending on the mass, and you would be the judge of that, but it does save you a little over 2 hours. Now there's even a cool or a fast fire or a speed sintering, I should say. Now the speed sintering is really for single units only up to 30 per batch. It's something to really be mindful of. And if you have like very heavy restorations, let's just say a screw retained molar, for example, I would honestly count that as 2 crowns rather than just 1. So just to be mindful of it, because it really has to do with the amount of mass. And again, it will all sinter, but it's the rapid cooling that, how is that going to translate to the mass? So just something to keep in the back of your mind. Again, it's indicated for up to 30 individual restorations. So that's a considerable amount of sintering that you can do in volume. But you have options here for a laboratory, whether it's 9 hours, 7 hours, or 4 hours. Most laboratories that that have been used transitions, and what I've seen a very popular kind of workflow in a sequence and a protocol is that they like to do the long bridges, the all-on X's overnight for 9 hours. That's kind of where laboratories have done for many, many years now, and they maintain that, as well as whatever they can stack it. There's no limit to how many you can sinter within the 9 hours, because it holds for a significant time and then cools over a significant time. So the 9-hour cycle is great, where before you leave for the day, you just send up the sintering, and then you come in the morning, everything is sintered, everything is ready for you to go. Then some laboratories they like rush cases, or even create a single sinterings. So I even know a laboratory that utilizes the speed cycle, the speed sintering, and they do 3 programs per day. So meaning that if they do 30 single crowns and they repeat that three times or 4 times, they can get up to 120 or more single restorations in a day. So it really depends on your workflow, but the options are there. The ability of creating whatever it is, the workflow that works best and most efficient in your laboratory to give you the optimal and the best results is available. So whichever side of the cycle you have here, you can absolutely operate, whether it's a 5, a 4, or a 3, whether it's a speed sintering or a 9-hour, the results will be the same. Now, keep in mind, the nice thing with transitions, as I said in the very beginning, you're able to get consistent and repeatable results. The shades are truly, truly remarkable. The incisal translucency is similarly truly remarkable. So when I became part of this, I was testing the Zirlux Transition zirconia. And my protocol was very simple. I milled all single centrals from the same STL, from the same design of the same tooth in various pre-shaded pucks, right? So I took the same STL and I dropped it in different shades, and then I milled it, sintered it according to the manufacturer protocol, as I just showed you earlier, and then just glazed it on the vacuum and took a shade tab to it. What I found was that the shade, the chroma gradient, translucency was absolutely remarkable. And this was when we first, just tested it before it was even pushed out to market or launched to market. And what's remarkable again, and what I saw right away, is not only are the shade consistent, especially some of the more difficult ones, but you have the appropriate chroma. But notice the incisal. This is something that is new, as far as I'm concerned, to a lot of the zirconias, because the value is appropriate, the translucency is appropriate, and the shade hits every single time. And if you recall, certainly the A3s tend to be very bright, and in other zirconias, as well as A35, and this has not been stained in any way. This has just been purely glazed. And matched with the shade tab. So the B1s, which other zirconias that I've had were just way too high in value, and I've always needed to tone them down slightly in order to match the incisal edge. Now the incisal edge here, or the incisal translucency, you can see the greatness, or you can even see on all these samples the halo from the way the light transpires through. So again, as I said, light either deflects, reflects, or goes through. When you have light going through and deflects at the same time, and the incisal edge is at a 45-degree angle on the lingual, is where you can get very nice halos. And that's what we see also in natural teeth, as well as in ceramic work, but that's been difficult to achieve with zirconia. One of the things that I first saw right off the bat is the translucency is true to the shade. You can see the gradation and you can see the halo in all of these. Similarly with the B1, notice the chroma is not the high value that we're accustomed to. The C3, which has always traditionally been a shade that's difficult to get with zirconia because of the high value and the nature of zirconia, this is without any stains. This is just being glazed and right out of the sintering oven. So it really is remarkable, as well as the D2 shade. Now the D2 shade has always been a challenge for me too, because even if we got the chroma correct, the value was always too bright, too high, and I always needed to tone it down. With the transitions, that just didn't happen, and it's really remarkable because it allows us to then be able to be more efficient, be able to be more productive, and create those restorations while consistently and repeatably hitting that shade every single time. Now, if you still wanted to go ahead and characterize it, you certainly can. Truth be told, I do as well, because I like it to be more than just the shade tab. So you can lightly stain slightly on the cervical and then into proximal lightly. But it's not necessary, because depending on your workflow, depending on the protocol, depending on the demand of your clients, you can hit the shade guide every single time, and it creates a much easier and more efficient workflow in a big way. There's not the need to spend the time to stain and glaze in order to achieve the outcome. It comes out of the shade every single time. Now, also with the way it's manufactured, depending, regardless of where it is in the puck, you have the same type of gradation or transition. So whether you are, at the end or at the edges of the puck, or more towards the inside or the center of the puck, you'll get the same consistent, repeatable result. The only criteria that is absolutely critical in the laboratory to make sure that you get those same results every single time is to make sure that the cervical end of the puck is truly on the cervical process of where your designs are going to go. So, and there's an arrow when you get when you purchase the transition puck, there's always an arrow showing you which side should be down. So you have to be mindful in the laboratory to make sure that the nesting technician places the puck in the right placement, so that you benefit from the transition. Otherwise, it's obviously in reverse. But if you do that well, and you place it and you nest it properly, and you use the right thickness of the puck, the results are truly remarkable, and you're able to get great results. And just look at the C3s, look at the B1s and the D2s, which have been traditionally difficult to attain with other zirconia lines. The transitions has really solved it in a big way, and it's just makes it so much easier. And talk about efficiency, talk about workflow. If you have to spend less time And again, what is the most costly aspect of operating a dental laboratory is labor. If you have to spend time with other zirconia lines or other materials in order to stain to get the shade, you're spending valuable time of your technicians where they could be producing more outcomes, more solutions, so that it's more profitable. So by having a consistent, repeatable shade results with the proper smart incisal, as you see here with transitions, you can actually produce more with the same labor costs, but produce more revenue. Everybody wins in the process. The laboratory is more profitable, and also the employees are able, or the technicians are able to benefit greater for the productivity and so on and so forth. So as a business sense, this the Zirlux transition is a great option as well. Now, in the IFU, one of the things that is really important is also recognizing what the sintering oven and how it does. So I took a picture of the IFUs, and also you can control the temperature and the chroma and the value with transitions. It's unique to how the sintering oven works. Now, I have to say, there is a calibration kit that can be purchased. There's also a purging cycle. Sintering ovens are incredibly important for the outcomes of zirconia, any zirconia for that matter. It certainly is the same with the transitions. Every sintering oven, even if it's the same brand, doesn't necessarily work the same way as another sintering oven. Just like ceramic ovens, we've learned to calibrate and utilize ceramic ovens. Now we have to relearn how to do that with the sintering ovens, because different brands, just because the temperature says a certain amount on the screen, on the digital display, does or does not necessarily mean that that's the temperature on the inside of the chamber. So by calibrating it, and it's a very simple process, there's calibration rings, and I know the Zahn sells them as well. It's the Transitions Zirlux rings, and you're able to place the ring into your regular sintering oven, and then once it removes and it cools off with your restorations, you remove the ring, you can measure that ring, and its geometric shrinkage will correlate to what the temperature was of the chamber. And sometimes 20 degrees will affect your chroma, as you see here. So for example, if it's a very low temperature of 1400, it becomes more opacified and a higher in chroma. 1450 is where you get the, more appropriate, but then it's less opacified. And the hotter it gets, you can see you're losing all the chroma, but what else are you getting? You're getting a lower in value, which may contradict your shade that you're trying to achieve. So understanding and calibrating and purging is how you really truly get control of your zirconia outcomes. So these are all materials that are available within your, when you purchase in your IFUs. But I also thought to place this up here because you can see exactly what the indications are. So for single crowns, 3-unit bridges, 4-unit bridges, how thick and how, which are all within the parameters of zirconia is what we've had typically. But it's something to adhere to and know, because this material is very versatile, but you want to make sure that you follow the indications to have the most appropriate outcome. But you will absolutely, I encourage everyone here on this call to certainly, at the very least, try the transitions. And I was completely blown away with testing it, and I'm happy to continue using it. And I believe that you will as well. So just as a recap, because I see that we're, it's a half an hour, and I appreciate your time. Zirlux Transition, again, it comes in all 16 shades, as well as in a OM2 bleach shade. Now the bleach shade is great. It has the same translucency, which is remarkable, as you would find in an A1 or an A2. So they're really well thought of everything, as well as the coloring is consistent and is closer to the shade tab than any other material on the market, as I said. It also is offered in a 98mm format, and it's available in a 14, 18, 22, and all 17 shades. Now, the true remarkable, this is a perfect case of where the transitions it's the restorations that were completed here. And this was an 8-unit case that we've done. And you can see the halo, you can see the translucency, you can see the chroma in the appropriate places, as well as the way it reflects and deflects light in a great way. It is proudly made here in the US, and what they've done is also they've created this for to give an extra assurance or an extra confidence to your dentist clients as well as their patients. What they're comfortable and they're recognized the dent alloy and dent ceramic certificates. So now this too it's another level. Not only the FDA has obviously approved it, but also it's another standardized level of confidence that the ident provides a certificate that you can then put on the prescription and share with your dental clinicians so that they know that the material is of premium, not only raw material, but also the premium quality that you're using and you're providing for their patient. It's something that adds, and I know that a lot of doctors really, really favor this, and it puts them at ease to know that you use the absolute best and premium of material for their patients and their practice. But truth be told, Transitions has translucency like no other. So developing, I mean, just kudos to the R&D department for, manufacturing this and developing this, because the shade formulations as well as the incisal is really spot on and the closest to impactful of the Vita shades every single time. And just when you put the backlight on these, and remember, these are zirconia restorations, and when you put the backlight on these, you can quite easily see the transitions, which is where I really feel not only is it chroma and as well as the translucency for the incisal, but really provides the laboratory with what I consider an absolute bullseye, a home run, and something that is really fantastic and makes laboratories' lives a lot easier. And the aesthetic and the value of what you get out of Transition is truly remarkable. So it's something that I encourage everybody to at the very least try. I'm confident that you will feel the same as I want after trying it. And it really changes the dynamic. I've spoken to some dental laboratories that have tried the Transitions, and they've actually changed their workflow because now they don't need to do the same with multiple lines of zirconia in order to accommodate certain indications. They're able to utilize the Transitions for everything under the sun when it comes to fixed or implant supported restorations. So with that, I know I spoke really fast. It was a half hour, and I wanted to give you the most amount of information and value out of this quick bite. But I just wanted to thank everyone from the bottom of my heart for joining us here, and hope you found some great value. And I'm happy to answer any questions you may have.
Thank you, Daniel. We do have two questions, and one is on sintering. We have an attendee who said they have sintered from 400 degrees Celsius to 1500 degrees Celsius and had unsatisfactory look. It almost looked chroma. So what should they do?
So it really, what I would suggest is there are two sintering ovens that are known to maintain their heat chambers a lot longer, meaning the insulation, and that sometimes throws off the temperature. What I would suggest is, because not knowing what kind of sintering oven this customer has, I would suggest calling the high-tech group. They're very well aware, and we've dealt with some of these consequences. We've narrowed it down to 1 or 2 sintering ovens that do have that, and we have remedies for that. Typically, it's dropping it, believe it or not, by another 100 degrees. And even though the chamber, the digital reading says 1500, it may actually be running as hot as 1600 or 1650, and therefore it changes it. So by dropping it, you get more of the translucency as well as the chroma, but it's really depending on the sintering oven that you have. And it's not just kind of a broad stroke, but certainly reach out to the high-tech team and they'll be able to resolve it. And if they can't, they can always contact me and I'd be happy to help as well.